Nitrogen pentafluoride. Nitrogen pentafluoride, NF5, is a theoretical compound of nitrogen and fluorine that is hypothesized to exist based on the existence of the pentafluorides of the atoms below nitrogen. Theoretical models of the nitrogen pentafluoride molecule are either a trigonal bipyramidal covalently bound molecule with symmetry group D3 or NF plus 4F, which would be an ionic solid. Ionic solid. A variety of other tetrafluoroammonium salts are known NF plus 4X, as are fluoride salts of other ammonium cations, Nr plus 4F. In 1966, W. E. Thalberg first synthesized a 5-valent nitrogen compound of nitrogen and fluorine when tetrafluoroammonium compounds, tetrafluoroammonium hexafluorotimonate, NF4SbF6, and tetrafluoroammonium hexafluorosinate, NF4 as F6 were made. In 1971, C. T. Goetschel announced the preparation of NF4BF4 and also produced a white solid assumed to be tetrafluoroammonium fluoride NF plus 4F. This was made by treating nitrogen trifluoride and fluorine with 3 MeV electron radiation at 77 K. It decomposed above 143 K back into those ingredients. Theoretical studies also show the ionic compound is very likely to decompose to nitrogen trifluoride and fluorine gas. Carl O. Christ synthesized bistetrafluoroammonium hexafluoronepalate NF429F6. He also prepared compounds with manganese, a fluoranate, a perchlorate, a fluorosulfate, and N2F plus 3 salts. Christ attempted to make NF4F by metathesis of NF4SbF6 with CSF and HF solvent at 20 deg C. However, a variant, tetrafluoroammonium bifluoride NF4HF2* and HF. At room temperature it was a milky liquid, but when cooled, turned pasty. At 45 deg C it had the form of a white solid. When reheated it frothed, giving off F2, HF and NF3 as gases. This has CAS number 71485-49-9. I.J. Solomon believed that nitrogen pentafluoride was produced by the thermal decomposition of NF4 as F6, but experimental results were not reproduced. Dominik Kurzadlowski and Patrick Zalesky engineered predict that a mixture of fluorine and nitrogen trifluoride under pressure between 10 and 33 GPa forms NF plus 4 F with space group R3. This is a high-pressure oxidation. Over 33 GPa it will form a stable ionic compound with formula NF plus 4 NF6F with space group I4/M. Over 151 GPa this is predicted to transform to NF plus 4 NF6 with space group 4/N. An NF5 molecular compound is not stable under any pressure conditions. Covalent molecule. For an NF5 molecule to form, 5 fluorine atoms have to be arranged around a nitrogen atom. There is insufficient space to do this in the most compact way, so that bond lengths are forced to be longer. Calculations show that the NF5 molecule is thermodynamically favorably inclined to form NF4 and F radicals with energy 36 kJ/mol and a transition barrier around 6784. Nitrogen pentafluoride also violates the octet rule in which compounds with 8 outer shell electrons are particularly stable. References ==